So in this video, we're going to go through the first part of Learning Target 5.3.1. So there is a Desmos that goes through this, and if you are watching this video, you can just kind of take notes as we go through this Desmos. If you want the link, you can email one of us to get the link. So in this learning target, we're basically finding all the same characteristics we did when we were looking at a graph, but now we are just looking at an equation. So we're going to talk about things like directionality, maximum, minimum, vertex, line of symmetry, and then both sets of intercepts. So we're first going to start with the directionality and whether or not we have a max or a min. Those are kind of related. So all of these quadratics are opening up. So looking at these equations, they are all opening up. And so I want you to pause the video and take a second and think about what they have in common, what tells us that they open up. So hopefully you notice that the thing that they have in common is that their A values are all positive. So their A values are all positive. And we can't really say anything about B because there's some that are positive, some that are negative, and we can't really say anything about C because, again, some are positive and some are negative. So A values are positive. And I'll tell you exactly what you need to write down when we get there, but we're going to kind of go through some mini explorations and then write something down. So and similarly, these are all opening down. Pause and take a second and see if you can figure out what they have in common to open down. And so again, if you can imagine, it's related to our A values. Our A values are all negative when they are opening down. So this is what you should write down. So directionality tells us whether the quadratic opens up or down. Those are the only two choices. And to determine that from an equation, if A is positive, we open up. And if A is negative, we open down. So you just have to look at your A value. Make sure you pay attention to whether or not the quadratic is out of order. A is always in front of the squared term. Make sure you get this written down. You can pause it if you need more time. But now let's practice it. So when we have a quadratic that opens up, so let's say we found the A value is positive and it's going to open up. We want to figure out if that means we have a maximum, a minimum, or neither of those things. So it tells me that I can sketch some graphs to open up to see what we have. So let's just sketch a couple graphs that open up. We have one like this, one like this. And so hopefully you can see from our examples that our vertices are all at the bottom. They are all, therefore, minimums. And so you can kind of imagine that every time they open up, you're creating a valley or a bowl. And so they will always have a minimum. And we'll write that down in just a second. Similar to the first question, if we open down now, you can see that all of these are going to have a maximum. So we're creating kind of a hill, and our vertex is always going to be at the top. So determine if we have a max or min. If it opens up, we will have a minimum because it looks like a U. And if it opens down, we have a maximum because it looks like an upside down U. And the big thing about this is this relationship kind of hurts our brains. Up and minimum don't seem like they go together, but they do. And then down and maximum, again, don't seem like they go together. So what always helps me is I always give this a quick sketch, is if I know it opens up, I'll draw a quick U, and I'll see, okay, it has a minimum. And if it opens down, I'll draw a quick upside down U and see that it has a maximum. Again, pause that if you need more time to get that written down. So those are the first two, the directionality and then max or min. Now we need to find the line of symmetry and the vertex, which we actually did when we did our graphing in standard form. So this is kind of just a reminder, but it'd be helpful to have in these notes as well. So the line of symmetry has its own formula when we are given a quadratic. And that formula is x equals negative b, over 2a. Negative b over 2a. So to find the line of symmetry, you need to use this formula, and then I kind of want to make sure that we have a little note here. Remember, this is always x equals a number. So you always have to have x equals the number. And then your line of symmetry helps you find your vertex because those two things are related. So to find the vertex, you plug your line of symmetry x value into the equation to find the y value. So the line of symmetry formula helps us find x, and then we plug it back in to find the vertex. So you take this and you plug it in to find the vertex. Go ahead and pause that if you need any more time. So this one's asking us for the line of symmetry of this formula. So it gives us kind of some area to sketch here. So I'm going to sketch this and you should write this work down. You should start by writing this equation. So you have that. And then our formula is x equals negative b over 2a. And I'm going to plug in my b and my a from my formula. So my b value is this minus 6. So don't get caught up in the double negative here. There is a negative there already. And then inside parentheses, we need a negative with our 6. So it's negative 6 over 2. And then our a value is 3. So if we simplify the top, negative 6 gives us positive 6, and 2 times 3 gives us positive 6. And we just need to divide that to get 1. So our line of symmetry is x equals 1. X equals 1. Now this is going to help us find the vertex. So this is our x value for our vertex, 1. And so now we need to find our y value. So it says we found the line of symmetry for this to be x equals 1. Great, I got the right answer. Now we need to find the vertex. So I'm going to take this 1 and I'm going to plug it into my equation. So I have 3 parentheses 1 squared minus 6 parentheses 1 minus 9. And you can type this whole thing into your calculator. So I highly recommend pausing it now and typing this in and making sure you get the same answer as me. If we type all this in, we should get negative 12. So my x value was 1. We found that from the previous equation. And then our y value is negative 12. And so the line of symmetry and the vertex are related. You have to find the line of symmetry first using that equation, and then you can plug it in to find the vertex. The last thing we need to do is find our intercepts. Thinking back to what we know, where can we find our y-intercept from equations? So here's a couple equations to help spark your memory. And think about what spot is the y-intercept. Hopefully you thought about it and said that the constant is the y-intercept, which it is. So our y-intercept is the constant in the equation, which means it has no variable. Remember to write this as a point, 0, comma, whatever the intercept is. So the y-intercept is the constant. If you need to pause it to get that written down, please do so. So now for each of these, it'd be helpful if you paused it and wrote down the equations first, because we're going to identify the y-intercept of each. This first one, the constant is 1.2. So remember, I want to write that as 0, comma, 1.2. My second one, the constant is minus 21. So 0, comma, minus 21. And this last one, my constant is negative 1200. So 0, comma, negative 1200. Now to find the x-intercepts, we have 3 methods that we have learned. We have learned the square root method, factoring, and the quadratic formula. Those are the 3 methods we have to find our x-intercepts, depending on what the quadratic looks like. If it's missing its b value, we want to use the square root method. If a is 1, we want to factor. And if we can't factor, we want to use the quadratic formula. So x-intercepts we need more time doing, so we're going to spend time in our next lesson working on just the x-intercepts. So for now, we're going to look at how do we put all this together. And after we do the x-intercepts will also be a question on here. So it's going to be all of this stuff plus the x-intercepts. So doing one full problem together, first thing it asks is what is the directionality? Well, directionality, I look at my a value. My a value is negative, so it opens down. Does this quadratic have a max or min? If it opens down, remember it looks like an upside down U, like a hill, so that means we have a maximum. The y-intercept is the constant, which is 8, so I have 0, comma 8. The line of symmetry is where you will need to plug your b and your a in to the formula. So we have x equals negative 2 over 2 times negative 1. So we end up getting our line of symmetry as x equals 1. So negative 2 divided by negative 2 ends up being positive 1. And the vertex, we want to take this x value we just found for the line of symmetry and plug it in. So you would have 1 inside parentheses wherever there is an x. And in that case, we get a positive 9. So 1, comma 9 is our vertex. And that's all. We're going to finish up the x-intercepts in our next lesson, but this was all of the other characteristics for equations.